In this session, we're going to see what factorials are. Factorials are denoted with an exclamation mark, and so I think they tend to look a little excited. For exclamation mark, it's like for factorial is how it's read. And the way we compute for factorial is we take the numbers that are starting with 4 and decreasing all the way to 1 and multiply them together. So 4 times 3 times 2 times 1. In other words, 24. That's 4 factorial. That's a factorial at its core. They aren't a difficult concept. It's just understanding what the notation means. So as another example, we could figure out 7, or 7 factorial, which would be 7 times 6 times 5 times 4 times 3 times 2 times 1 all the way down the line. And some quick button pushing tells me that 7 factorial is equal to 5,040. So it's just the result of multiplying all of the numbers that are up to and including the number that has the factorial. And we're only talking about the natural numbers, and so all the way down to 1. A lot of scientific calculators have a button. Maybe it looks like X with an exclamation mark, X, or it may be in the PRB menu, PRB meaning probability, and that's where these get used a lot. And it is also useful to see how factorials can be mixed with other operations. For instance, 7 factorial divided by 4 factorial. If we expand the factorial in the numerator, we have 7 times 6 and so on all the way down to 1. And then of course in the denominator, we just have 4 times 3 times 2 times 1. And we see that we have factors that are common that divide out. And so what we're left with is simply 7 times 6 times 5 for a result of 210. Now once we get savvy with factorials, we'll realize that 7 factorial is actually 7 times 6 times 5 times 4 factorial, right? And in the denominator, we of course have 4 factorial. So if we want to kind of reduce the writing that we have and cut to the chase of what's really going on, 7 factorial divided by 4 factorial could be represented by 7 times 6 times 5 times all the rest of them, which is denoted 4 factorial. And then in the denominator, 4 factorial, and then you only have, you have less to divide out, right? It's of course the same result no matter how you write that. And then we might see a situation where we combine them in a little more interesting way. 7 factorial divided by, let's say, 4 factorial times 3 factorial. Well, the 7 factorial is 7 times 6 times 5 all the way down the line. And the 4 factorial is, of course, 4 times 3 times 2 times 1. I just write the 1 for completeness. The 3 factorial is 3 times 2 times 1. And what we're going to do is we're going to divide out common factors in both the numerator and denominator. And in this case, the 6 and then 4, 3, 2, 1 all divide out with factors that we see in the denominator. And what we're left with is simply 7 times 5 for a result of 35. Now, before we're done with this topic, we do need to go over just a couple of things. One of them is like kind of an obvious one. 1 factorial, or as I say, 1 is equal to 1, right? That's duh, why'd you tell us that? Because I wanted to. 0 factorial, though, is 1 by definition. And when we say by definition, that means there's nothing to understand. There's not a fact or a concept that I can explain to you to help you wrap your mind around 0 factorial is 1. It's a definition. At this point, you just go, oh, okay. I didn't hear you. Okay, yeah. Oh, okay. That's all you say. So 0 factorial is 1. 1 factorial is 1. All the other factorials, say n, or n factorial, are the result of multiplying a number by all of the natural numbers all the way down to 1. So n factorial would be n times n minus 1 times n minus 2 times I don't know how many numbers, but it ends with times 3 times 2 times 1. And those are factorials.